The urban heat island effect describes how cities become hotter than their surrounding rural or suburban areas. This happens because concrete, asphalt, and buildings absorb and store heat, while green spaces that cool the air through plants and trees are often limited. The result is a noticeable temperature difference that affects comfort, energy use, and even public health. Most studies on urban heat islands focus on buildings, roads, and air pollution. But a recent study highlights another overlooked factor: cars. Cars not only emit heat when driven, but their materials and colors significantly affect how much heat they absorb and release into the environment. Researchers in Lisbon set out to measure this effect. They placed a black car and a white car in the sun on an asphalt parking lot, then measured air temperatures around and above them. The results were striking. The black car raised the surrounding air by almost 4 degrees Celsius compared to asphalt alone. The white car also warmed the air, but much less intensely. Just 20 centimeters above the roof, the black car was about 1 degree hotter than the same spot over the white car. This happens because darker surfaces absorb more solar radiation. White cars can reflect up to 85% of sunlight, while black cars reflect only about 5 to 10%. Add to that the thin metal panels of vehicles, which heat up faster than asphalt, and suddenly, cars become major contributors to local warming. In a city filled with parked cars, especially dark-colored ones, this effect multiplies. The Lisbon study even modeled what would happen if most cars were lighter in color. They found that switching vehicles to white or reflective coatings could significantly increase the city's overall reflectivity, or albedo, reducing heat absorption in certain neighborhoods. Of course, asking everyone to buy light-colored cars isn't realistic, but urban planners can take steps to address the problem. Strategies include shading parking lots with trees or reflective canopies, encouraging the use of reflective pavement, and designing greener city infrastructure such as rooftop gardens, facade vegetation, and urban corridors to promote cooling through shade and evapotranspiration. The findings remind us that even small design choices, like vehicle color or parking layout, can influence how hot our cities become. In the face of climate change and rising urban populations, these insights are valuable tools for creating cooler, more livable environments. Thanks for watching.